Welcome back to part 2 of section 1.6, talking about our parent functions. Now, what we're going to be talking about today is what's called a piecewise function and then a step function. Now, we've talked about evaluating piecewise function. Now we're going to graph a piecewise function. So what we have here is we have two functions. Y equals 2x plus 3 and y equals negative x plus 4. So we're going to use the top function when x is less than or equal to 1 and the bottom function when x is greater than or equal to, greater than 1. So what I'm going to do, just to make my life a little bit easier, I'm going to make a table of values. I find this is a quicker way to do it. So when x is negative 3, negative 2, negative 1, 0, and 1. So we're going to use that top function. So that's going to be 2 times negative 3. So negative 6 plus 3 is negative 3. When x is negative 1, y is negative. When x is negative 2, y is negative 1. When x is negative 1, y is positive 1. When x is 0, y is 3. And when x is 1, y is 5. And that's just from substituting into 2x plus 3. So I'm going to plot those points. So I'm at negative 3, negative 3, negative 2, negative 1, negative 1, 1, 0, 3, 1, 5. Now, for that last point, because it's less than or equal to, I'm going to use a solid dot at that point. And now, I'm going to draw, knowing that it's the same function for that entire left-hand side. So you can see it has a y-intercept at 0, 3, and the slope is 2. Now for the next function, for that negative x plus 4, we're still going to use the 1 to give us a starting off point. We're going to use an open dot there, though. We have a 1, a 2, a 3, and a 4. So when x is 1, negative x plus 4, so negative 1 plus 4 is 3. When x is 2, you get 2. When x is 3, you get 1. When x is 4, you get 0. And we'll throw a 5 on there, you get a negative 1. So we'll plot those points. So we're at 1, 3, 2, 2, 3, 1, 4, 0, 5, negative 1. And you can see the slope is just negative 1. We just keep going down. Now, looking at that domain, we have x is greater than 1, which means we're going to use an open dot at that point. And because of that open dot, it's allowing us to have a function because it would pass the vertical line test. So there is our piecewise function. So our domain, all real numbers. So we're going from negative infinity to positive infinity because we used all of our possible values for x. Now our range, the highest point it reaches is at 5. So the range is going from negative infinity up to 5. So we're going to put a bracket at 5. The intercepts, the x-intercepts, there's 2 of them. Now you could find them algebraically, and we'll do that for the top one. So for y equals 2x plus 3, 0 equals 2x plus 3. So when we solve, negative 3 equals 2x, divide by 2, x equals negative 3 halves. So we have an x-intercept at negative 3 halves, 0, and the other x-intercept is at 4, 0. We can see that from the table and from the graph. Our y-intercept is at 0, 3. There's no symmetry, so it's neither even or odd. And now for increase and decrease. It's increasing on the left-hand side. So it's increasing for values of x from negative infinity up to 1, parentheses there as well. And it's decreasing from 1 to positive infinity. That is a piecewise function. We'll do another piecewise function now. So we have 2 when x is less than or equal to 2 and when x is greater than or equal to 2. So we'll do the top one first. So we'll make a table. In my opinion, just makes things a lot easier. So we're going to pick some values that are less than or equal to 2. So -2, -1, 0, 1, and 2. So it's 1 minus -2 minus 1 squared. -2 minus 1 is -3. Squared is 9. 1 minus 9, so it's going to be -8. And you can keep substituting those values. You'll get -3, 0, 1, and 0. So we're at -2, -8. We're down here. -1, -3, 0, 0, 1, 1, 2, 0. Now, once again, because of that or equal to, we're going to use a solid dot at 2, 0. Now, for the bottom function, x and y, x is greater than 2. We're still going to use 2 as our starting off point. So we'll have a 2. I'm going to pick some values that are easy to work with. So we're going to pick a 3, a 6, and an 11. And the reason I picked those points is 2 minus 2 is 0, and the square root of 0 is 0. The 3 for x, 3 minus 2 is 1, the square root of 1 is 1. It's giving me nice whole numbers. 6 minus 2 is 4, the square root of 4 is 2. 11 minus 2 is 9, the square root of 9 is 3. So we're at 2, 0 once again. We're at 3, 1, 6, 2, and 11, 3, which would be up there. Now we're using an open dot at the 2, 0, but you can't see it because it's covered up by the solid dot. So the left-hand side of the graph goes like this. And the right-hand side looks like that. That's the piecewise function. That is our piecewise function. Let's do one more piecewise function, then we'll get into the step functions. Here we have 3 pieces in our piecewise function. So we'll start with the top, then the middle, then the bottom. So we'll make a table, x and y. These are for our values less than or equal to -1. So let's do like a -4, a -3, -2, and a -1. 2 times -4 is -8. -8 plus 1 is -7. Then we get a -5, a -3, a -1. So we're at -4, -7, -3, -5, -2, -3, -1, -1. Now, because of that or equal to, we're going to use a solid dot right there. Now for our middle function, this is for our values of x between -1 and 1. -1, a 0, and a 1. 2 times -1 squared, so -1 squared is 1, times 2 is 2, plus 3 is 5. So then when x is 0, we get a 3, and when x is 1, we get a 5. Now, when we plot those points, we're at -1, 5. We're at 0, 3, 1, 5. Now, looking at those, because we have the just less than, this is an open dot here, and we have the less than or equal to, which means at the bottom, that's a closed. So we have 2 types of dots. We have an open up here and a closed over here. And then we sketch our graph. Oh, forgot to draw the line over here. There it is. And you can see it's going to pass the vertical line test because one's open, the other one's closed. And now 1 minus x squared. Once again, we'll start at 1. And then we'll do a 2, a 3, and a 4. 1 squared is 1. 1 minus 1 is 0. And then when x is 2, we're at -3, then -8, and -15. So we're at 1, 0. We're at 2, -3. We're at 3, -8. So now, based on our inequality sign there, this is an open dot. And that's allowing us to pass that vertical line test, making this a function. Now, it's not really a line, it's really like a curve. We're just not really seeing enough points to see how gradual that curve is. And there is that piecewise function. Then to finish up, we're going to talk about a step function, and let's do that in the next video.